Hello students, my name is Deepika and I'm working as an assistant professor in Chandigarh Polytechnic College of Computer Science and Engineering Department. So in our previous operating system lectures, in process concept we discussed about the introduction of process. What is process? What is the difference between process and program? And then we already discussed about PCB, process control block, and then we discussed about what is process states? What are the various states of a process? Like there are five various states of a process: new, ready, running, terminated, and waiting state. So now today we discuss two more concepts related to process scheduling. First is schedulers, and then is scheduling criteria. Before going toward scheduling algorithms for CPU scheduling, we discuss about what we understand by schedulers. What is schedulers? What are the types of the schedulers? And then we discuss about what is scheduling criteria. What are the various factors when we do scheduling? What are the various factors we must keep in mind? So first, what is schedulers? Schedulers actually it is a system software which handles process scheduling in various ways. There are lot of processes in job queue. We already discussed job queuing process concept. There are various processes that enters into a job queue. Which process got the CPU and which process don't get the CPU. This is decided by the schedulers. At a time, which process is allocated with the CPU, which process is going in the running state. This all is done with the help of the schedulers. So schedulers are the system software that handles the scheduling concept. And its main task is to submit the process from job pool and decide which process will get the CPU. So schedulers are of many types. First is long-term scheduler. Basically, it is of three types. First is long-term schedulers, second is short-term scheduler, and third is medium-term scheduler. So, what is long-term scheduler? What is short-term scheduler? And what is medium-term scheduler? We will discuss all these three types of scheduler. So, first of all, long-term scheduler. Long-term scheduler is a job scheduler. It is a job scheduler. See, there are three types of queues we already discussed. First is job queue, ready queue, and waiting queue. So when a process enters into a system, it first enters into a job pool where all the jobs that want to get the CPU, that want to run in the system, they all come in the job pool. So long-term scheduler is also called the job scheduler. Its task is to select the job, select the process. I use process and job interchangeably. They both are the same terms. So long-term scheduler selects the process from the job queue and put it into the ready queue. Ready queue means then it gives main memory. If the process now resides in the main memory. So from a lot of jobs which is residing in the job queue, what job scheduler is doing? It select the job, it select the process from the job queue and put it into the main memory. That is known as ready. So what are its objectives? Its objective is the control of degree of multi-programming. Multi-programming actually is possible when there are lot of processes, lot of programs enter into the system and they reside in the job pool. They reside in the job queue. And second other objective is a balanced mix of jobs such as input output bound and processor bound. Actually, when it selects process from the job pool, it selects the mixed types of job. It selects some 50% jobs from input output bound and 50% jobs from processor bound. And it also controls the degree of multi-programming. Means its important task is to change the state from new to ready. New to ready. New state means when the process is getting created. It is created at that time. And long-term scheduler, after the creation of the process, it puts the process into the main memory. So it is called the ready queue. So it is the task of the long-term scheduler. Second is short-term scheduler. Short-term scheduler is also known as CPU scheduler. Now it's time to allocate CPU to the jobs that are residing in the ready queue, that are in the main memory. But long-term scheduler did. Long-term scheduler selects the job from the job queue and puts it into the ready queue. Now it's the task of short-term scheduler. It selects the job from where from ready queue that is in the main memory, and it gives the CPU to the job that is being decided by the CPU scheduler. Short-term scheduler is also termed as a CPU scheduler. So its task is its main function is to change the state from ready to running. Because that state when the process is in the ready queue is known as the ready state, and when the process is allocated CPU, that is called the running state. So short-term scheduler is also known as dispatcher. It makes decision which processes to execute next. So it is faster than the long-term scheduler because we know a lot of processes are there, and CPU is running. CPU at a time is running a lot of processes one by switching by doing the context switch between the processes. So main objective of the short-term scheduler is to increase performance so that the CPU never becomes idle. If any time a process is running in the CPU and it wants to get input output, it wants to perform some input output operation. So at that time, what short-term scheduler do? Short-term scheduler selects the job from the ready queue and then it submits the job to the CPU. And at that time, CPU never becomes idle. So it increases the performance of the short-term scheduler. So next is third one is medium-term scheduler. Medium-term scheduler is the third category of the scheduler. It is also known as swapper. It performs the task of swapping. For example, some process is in the CPU. So what it will do, the medium-term scheduler actually handles the swapped out processes. Okay? So maybe some process when it is running in the CPU, it requires some input output request. So at that time, that process doesn't reside in the CPU and wait for the input output because CPU becomes idle at that time if that process becomes doing the wait in the CPU. This is not a best solution. So at that time, what medium-term scheduler is doing, medium-term scheduler swap the process, suspend the process for completing the input output request. So what it will do, it will swap the process from the main memory and then it will again swap in the process to the CPU. So it will do the swap out basically, swapping from main memory to secondary memory. This is known as medium term scheduler. So these are the three schedulers. First is long term scheduler, second is short term scheduler, and third is medium term scheduler. So they perform the task of scheduling. They perform the task of scheduling in various queues. Scheduling in various queues like from job queue to uh, ready queue, from ready queue to CPU, and then from main memory to secondary memory. This all is done with the help of the scheduler. Next, we go to the scheduling algorithm. Because scheduling is very important task is to be done with the help of the operating system in case of multi-programming operating system, because there are lots of jobs and it will not be there that one job is running, one job is allocating CPU and it will take CPU till it doesn't gets completely executed. Why these other jobs have to wait? Starvation problem will occur. So to avoid all these situations, scheduling is very important task which is to be done with the help of the operating system. So before going towards the scheduling, we will discuss some scheduling criteria. What are the various criteria that we must keep in mind while doing scheduling? There are 5 basic criteria. First is CPU utilization. Our main and important motive is to keep the CPU as busy as possible. It will not be there that some jobs are waiting in the job pool, some jobs are waiting in the ready queue, and CPU sits idle because of some other job that is doing some input output. Second is throughput. Throughput is the number of processes execution, completed execution per unit time. So throughput, we want that throughput will be very high. What will be the maximum criteria while doing scheduling and what will be the minimum criteria? We will discuss all these also. What will be the maximum and minimum criteria? We want CPU utilization to be maximum. What we want CPU utilization to be maximum. And we want throughput to also be maximum. Number of processes that is executing per unit time, we also want that it becomes maximum. Next is turnaround time. Turnaround time is the amount of time to execute a particular process. When a particular process becomes submitted to the to total time, that is from the submission to the completion of the job. That is the amount of time to execute a particular job. And turnaround time criteria will become minimum in case of the scheduling. We want to optimize this criteria by minimize turnaround. Next is waiting time. Waiting time is that is amount of time the process has been waiting in the ready. Because process has to be in the ready queue for the waiting of the CPU, because in CPU some other process is going on. So what it will do at that time? This time is known as waiting time, and everyone wants waiting time to be minimum. We want to optimize these criteria, and waiting time must be minimum in that. So what is the optimization criteria here? We want to minimize the waiting. And last one is the response time. Response time is the amount of time it takes, any process takes. It means any process takes. Amount of time any process takes from when a request was submitted until the first response is produced. I'm not talking about the output. I'm talking about first response. Maybe some processes executing from uh, maybe some processes divided into different modules, and the output of first module when received, that is called first response. So it is called response time. So response time is the time when the process is submission between the time and when we receive the first response. This is called response time, and we want response time also to be minimum. So these are the some optimization criteria. There are 5 scheduling criteria, and these are the optimization criteria for these scheduling algorithms. First is CPU utilization. We want to maximize the CPU utilization. And then is maximum throughput. Maximize the throughput. Number of processes running per unit time, we want it to be maximum. Next is turnaround time, it will be minimum. Waiting time, we also want to minimize it. And then is response time. Response time, we also want to minimize. So these are the some criteria, scheduling criteria and optimization criteria. So next is scheduling algorithms. There are various algorithms. There are various scheduling algorithms like scheduling algorithms. So various scheduling algorithms are available, which we will discuss in our next lecture, but we will discuss the types of the scheduling algorithms which are provided by the operating system. On which basis operating system decides which process will come from the job pool to ready queue and which process will come from the ready queue to CPU. Actually, scheduling algorithms decides which process at that time gets the CPU. So there are various types of scheduling algorithms available. So first of all, algorithm basically divides into 2 types. First is preemptive and second is non-preemptive. So basically, it is broadly classified into 2 types. First is preemptive and second is non-preemptive. Preemptive. Preemptive, as its name is preemption. Preemption means when any process is executing in the CPU. For example, P1 is executing in the CPU at this time, and some other higher priority process comes and that want to execute. So that P1 process will get printed from the CPU and CPU will get allocated to the process P2, which is of higher priority than P1. This is known as preemptive algorithm. Means any process which is running in the CPU, which is having a CPU at that time, that process must be preempted. That process must be switching from the CPU due to some other reason, due to priority, due to shortest job first process, and many other reasons are also available. Like in round robin preemption is there. After that, time quantum finishes, the preemption of the processes will become there. And next is non-preemptive. Non-preemptive means once CPU is allocated to one process, for example, CPU is allocated to P1. Now, when the P1 completes its execution, after that P1 releases CPU for other processes. Means in between P1 process doesn't preempt. This is known as non-preemptive algorithm. At a time a CPU is allocated to process P1, and when the P1 gets completed, after that it will get preempted from the CPU. After that, any new job will get the CPU. So these are called preemptive and non-preemptive algorithms, and under this category, various algorithms for CPU scheduling is available. So first is first come, first serve. First algorithm is first come, first serve. We will discuss the detail of these algorithms in the next lecture. And second is shortest job first. Shortest job first. Third one is shortest remaining time first. Shortest remaining time first. This is also called preemptive SJF. Shortest remaining time first is also called preemptive SJF. And next one is priority algorithm. And last one is, this is priority algorithm is fourth category of algorithm. And the last one is round robin algorithm, which we call RR algorithm. So these are the 5 types of scheduling algorithms under the category preemptive and non-preemptive. Every algorithm will be preemptive as well as non-preemptive, except one or two algorithms. So first is first come first serve, second is shortest job first, shortest remaining time first, and shortest remaining time first is also called preemptive shortest job first. Job first. And next is priority algorithm, and next is RRR, stands for round robin algorithm. So this is all about today's lecture. We discussed about schedulers, its types, that is long-term scheduler, short-term scheduler, and medium-term scheduler. And then we discussed about the various scheduling criteria like CPU utilization, throughput, response time, turnaround time, and waiting time. And then we have seen various types of scheduling algorithms, in which first broadly classification is preemptive and non-preemptive, and then there are various algorithms that exist for CPU scheduling is first come first serve, shortest job first, shortest remaining time first, preemptive which is also called preemptive shortest job first, and then priority algorithm and round robin. I hope all these topics have been clear to you, and we will discuss the detail of the scheduling algorithms in our next lecture. So take care, and we will do the explanation of